All right, so to understand differentiation, we need to understand limits. And limits are possibly the most confusing thing you're going to come across in this topic. So with respect to maths, a limit is something, a value that it is approaching, okay? So if we're talking about a function and it's continuous, so our function is fx, if it's continuous, then when x equals a, the limit of fx equals fa. And if I'm writing that as I should, it's actually limit approaching a of fx equals fa. Now that makes absolutely no sense. No. Okay, but basically what it's saying is as you approach a, then the function of fx is going to equal fa the closer you get to it. Now that sounds kind of stupid, doesn't it? If you're approaching, as x approaches a, I forgot the x there, as x approaches a, fx is going to equal fa, or it's going to get really close to it, isn't it? That's all that's saying. Okay? If our variable is approaching a value, then our function is approaching the substitution of that value in. Okay? If fx is a constant, okay, so fx equals c, then it doesn't matter what your x value is, your limit of fx as x approaches a is going to always be c because it's a constant. Okay. The third, so that's 2, that's a 1. The third thing you need to worry about, limit as x approaches a of fx plus or minus gx. Okay. You can break that up. It's the limit as x approaches a of fx plus or minus the limit as x approaches a for gx. Okay, so you don't have to do both at once, you can do them each separate. Yeah? The fourth one you need to worry about is the limit as x approaches a of fx times gx is actually the limit as x approaches a of fx times by the limit as x approaches a of gx. Okay, so basically what it's saying is limits, you don't have to do them together. So if you've got function f times function g and you want to find the limits of those, you can find the limit of f and multiply it by the limit of g. Okay, same as if you're adding or subtracting. You can find the limit of f and subtract g, or find the limit of f and add g, depending on what it's asking you to do. Okay, extremely what looking? Neat. Not. And it's the same for divide. Limit as x approaches a of fx on gx is equal to the limit as x approaches a of fx divided by the limit as x approaches a of gx. Alright, so what does that mean in practice? Nothing. Okay, at the moment it means absolutely nothing. So let's actually go and put it into practice. Alright, all of that is just basically saying the most important one for you guys to know at the moment is number 1. Where if it's a continuous function, as you approach x equals a, then you substitute a in to find the value. So for a start, I'm going to skip the first 8 questions out of exercise 9a. So we're going to start with question 9. Okay. It says the limit as x approaches 2 of 2x plus 5. We need to evaluate that. We're not allowed to use a calculator. What does my first rule say? What does the first rule of limits say? when x approaches a, the limit of fx is going to be fa. Okay, so in this case here, I'm going to substitute x equals 2 into this, and that'll be the limit as x approaches 2. So as x approaches 2, I'm going to get close to that, no matter which direction I approach 2 from. So what does that mean in a graph?
2 equals 9.
Yeah, you're right. Okay, so if I follow this line, as I get closer to 2, what does my y value get closer to as I go up this line?
2.
If I come down this line towards 2, no, y value, 9.
9.
As I come down this line approaching 2 on the x-axis, what does my y value approach? 9. So no matter which direction I go on this line, as I approach x equals 2, I'm going to approach y equals 9. That's all this limit stuff is about.
So with limits, is that where it stops at 2, 2, 9? Or does it keep going?
Well, as you approach it, that's what you're going to get to. So what that means is, I get what you're trying to get to, but don't try it. All right? It's just going to confuse you more later. So at the moment, all you need to worry about is the fact that as I approach this value here on the x-axis, what do I get on my y-axis? What am I getting closer to? Okay? Because that's what's going to help you understand the next part of this limit stuff. Okay? So now that we've got that section out of the way, which is all these confusing formulas, right, that we talked about, we're now going to go back to basics. So let's go have a look at question 1. Okay? Question 1 says we've got 4 plus 2 plus 1 plus 1/2 plus 1/4 plus blah, 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 blah. What is that going to approach the more values I add together? And how can we work it out? We're not allowed to use a calculator. So how can I work out what this is going to approach? Add them. So 4 plus 2 is 6. 6 plus 1 is 7. 7 plus half is 7.5. Plus 1/4, 7.75. Plus 1/8. What are we getting closer and closer and closer to? 8. All right, so the more we add, we're never actually going to reach 8. We're always going to be a fraction smaller. But we are going to get closer and closer and closer to 8. So we are approaching 8. So we'd say the limit of this here is 8. All right. Now if we have a look at question 2, the diagram shows regular polygons with 3, 4 and 5 sides. Number of sides get very large, approaches infinity. What shape are you going to get? The more sides you add to the shape, what shape are you going to approach? A circle, because it has infinite sides. Now that's actually really, really important, and the reason I'm actually doing this question, even though it is quite simple, is because how many tangents does a circle have? Infinite. Okay, because remember, a tangent touches the circle at any given point. Okay, so all of those red lines are tangents to that circle. Tangents are what we're going to be working with as we move into differentiation, because differentiation is all about the gradient. Okay, and these limits help us work out the gradient at a point. That's what this is all about. All right, so let's have a look at question 4. We've got this, so question 4a, we've got this 1 on n, and n is approaching infinity. What's the limit? What value am I going to get to as n approaches infinity? By definition, what's infinity? What is it by definition? No, not quite what I'm looking for. As a number, what is it? Massive. So what's 1 divided by a massive number?
That number?
No, that'd be that massive number divided by 1.
Big number?
No, 1 divided into a massive number of pieces is going to approach what?
0.
Yeah, it's going to approach us really, really, really small piece. So we're actually going to approach 0. we're going to get closer and closer to 0. The higher we put this, the higher we put n in, the smaller our piece will get. So we'll actually approach 0. Now we'll never actually get to 0, but we will get closer and closer and closer to it. And then part B says to write that using limit notation. Limit as n approaches infinity of 1 on n equals 0. Okay, so that's the limit notation. Make sense? Okay. The last question you guys need to concern yourself with, the rest of it's pretty straightforward, but I want to talk to you about question 8. Okay, and they've got graphs here. There's a graph that does something like that. That's not quite right, but it'll do. That's 4. That's 14. Okay, so that's close enough to the graph. It's not very good. But the question asks you to find the limit of fx as x approaches 4.
14.
It's 14 because that's what my y value is approaching, okay? So like we did with the linear one up here, if I come from the bottom up, I'm approaching 9 on the y-axis when I get towards 2. If I come from the top down, I'm approaching 9 on the y-axis as I approach 2. The same thing here. As I approach 4 on the x-axis along this line, I'm getting close to 14 on the y, whether I'm coming from the top or from the bottom.